imagine a future in which a patient goes to the hospital, drops off a sample of his or her tumor, has it analyzed in real time by a CAD system that then produces the gene therapy or drug combination necessary for the cure? I thought this sounded like science fiction too until I started my work on this project. The truth is, this type of a system may be possible a lot sooner than we think. As we speak, biologists are gathering a lot of circuit-like information about the computational pathways and networks within our cells. With the advent of new technology, we can figure out exactly how cancer cells manage to grow in an uncontrolled manner. Here is how.
In this project, we analyze cells using a mass cytometer. Mass cytometry is a recent technology that allows to measure up to 100 parameters on the single cell level. Now, how does the mass cytometer work? In our case, we remove systematically parts of the cellular information processing system. To read out the effects on the rest of the signaling network components of each single cell, we label these with metal isotopes that we can attach to these components using so-called antibodies. Then we inject the single cells into the mass cytometer. Here they enter the plasma, which is extremely hot, close to 7,000 degrees Celsius, where every single cell is broken apart into its single components, and also all of these components are then ionized. And then we measure only the metal isotope ions using a so-called mass analyzer, a mass spectrometer. And as a result, we gain a quantitative measure of the single cell metal isotope content. And as we know for each single isotope on which antibody it was bound to, we know about the marker abundance of the single cell. And therefore we also know how removing or silencing a specific component in the cell affected all of the other components of the signaling network that we are interested in.
Come to my WACI talk if you want to learn more about how CAD can cure cancer.